The history of humankind is marked with significant achievements, often inventions or discoveries that improve the human condition. What will history write about these innovative days of biotechnology? Will it say how we advanced to new heights? Our understanding and response to serious disease? That we used biotechnology to meet and surpass the world's ever-growing demand for food? And that we learned to produce clean, renewable energy? Or will history merely state the obvious? Biotechnology is improving the human condition. Biotechnology, healing, fueling, and feeding the world.
I think any new technology, when it's first introduced, causes some concerns, either health or environment or religious concerns, and all of them have some basis in fact. When insulin was first introduced, there was concerns that we were now trying to take a human hormone from a bacteria, and would it be safe? Would it have some secondary effects? As time has shown, the insulin produced by biotechnology is remarkably safe, remarkably effective, and very cost effective. We're going in the same direction in plant-made pharmaceuticals. There's a research in place today to make the first human cancer vaccine in tobacco plants. When that vaccine comes out and is available to the general public, I don't think anyone will ask, how did you manufacture it? Did this come from plants, or did it come from animal cells, or whatever? They'll just say, we have a cancer vaccine. And suddenly the stigma of plant biotechnology and genetically modified crops will be lost, and we'll begin focusing, as we should, on the products that are coming out and how useful they are.
This is the start of a pivotal change, because this is shaping up to be the beginning of the biological era, because we've seen farmers mastering weed control and bug control, and in the not too distant future they're going to be growing crops that are nutritionally better and are grown with less water to yield more. The thing that fascinates me with these crops is whether you're a 1 acre farmer or a half acre farmer in India or a 1,000 acre farmer in the Mississippi Delta, the benefits that you get from these technologies is exactly the same. And the yield returns are exactly the same. And the cash that comes back into your enterprise is exactly the same. And as I look to the future, and I don't think it's the too distant future, those self-same benefits will translate into sub-Saharan Africa, where you'll have a farmer there planting a seed for the first time that yields more with less water. And I think in the next 10 or 15 years, we're going to look back and smile at the beginnings of this industry, whether it's in medical or it's in agricultural biotechnology, because we're now beginning to turn the page on producing enough crops to drive or satisfy our demands for food, for feed, for fuel and for fibre. And I think 10 years or 15 years from now, looking back, we'll wonder why we even debated that this was possible.
Rotarix is interesting. I think it was Bill Gates who said, I can't believe that there is a disease that kills 600,000 children a year that I've never heard of. And he was speaking of rotavirus infection. And everybody has had it, all of us in the developed world and in the developing world, but nobody knows the name of rotavirus. It's diarrhea and severe vomiting in babies. And in the US, it causes quite a lot of hospitalization and economic burden. So we're developing vaccines for travelers as a commercial market. But the same diseases that will ruin your business trip or your adventure trip are actually killing children in those places where travelers are going. So we're trying to do that part of it, the global health development, with the help of the NIH and agencies funded by the Bill and Melinda Gates Foundation.
I think there will be two events of memory 200 years from now about today. The first will be the recognition of the individuality of disease and response to therapy. That's molecular biology. The granularity of our understanding what a disease is so much more intense now than it was just a few years ago. Whether that's understanding what kind of a tumor you have, or whether it's understanding how your tumor is different than mine, even though it's the same kind of cancer. So the ability to make therapies more customized to individuals in terms of the idiosyncrasies of their illness and their individual responses to drugs will be one of the things that we look back on the turn of the 21st century with fondness about. The other side, I think, will be the recognition that we can go beyond pills and scalpels and truly harness the power of regenerative medicine. And that's what we're trying to do with our embryonic stem cell program.
We believe that every tissue and organ has cells which are focused on regeneration. What Tenjian has done is we've unlocked the ability to isolate those cells, grow those cells, and put them onto the right type of scaffolding material that once implanted back into the body, catalyzes the body's natural ability to regenerate. What we're doing is we're taking the cells that we've grown. We grow out a tremendous number of cells. Those cells are then coated onto a biodegradable scaffold that's in the shape of the organ that we are trying to treat. That cell-seeded scaffold, if you will, is then sent back to the patient's surgeon, where it's implanted back into the patient. It functions as an organ, but the most important thing is it actually catalyzes the body's natural ability to regenerate an organ. The body says, oh, I know what this is. This is a very early stage bladder. I grew one of these for this patient before. I still know how to do that, so I'm going to fill it in. I'm going to grow in all of the tissue layers that are required in a normal bladder. I'm going to vascularize this organ. I'm going to bring blood to it, and it's going to function and develop like a normal organ. Over time, this scaffold material slowly dissolves, and it's replaced with normal bladder tissue that the body has laid down. The body has regenerated.
Biotechnology is about life, and life is about carbon. And 80 or 90% of the world's energy is also about carbon. And so you might expect that there would be great synergies between biology and energy. We are pursuing the application of advanced biotechnology and biology to do transportation fuels. Not just ethanol, but substances such as butanol. It has a higher energy density, 90% of gasoline as opposed to 70%. It also isn't as corrosive, it's not hydroscopic, and of course you can run it in your engine without any significant modification at all. Biobutanol will be far superior to ethanol in terms of powering transport, all derived from energy crops.